We've got a change up in the podcast room today. We've got the beautiful Zemon here with me.
Hello.
So I'd just like to acknowledge that we meet on the Ghana lands and we pay our respects to elders past, present and emerging. And I'll hand over to Zemon, who will give us an introduction to Jason, who I'm super excited to chat with today.
Jason Quinn is the founding director of Sustainable Engineering Ltd. His work focuses on the intersection of physics and building design, and he has outspoken views on New Zealand housing. He has degrees in mechanical engineering and aerospace engineering and is a registered international professional engineer and a chartered member of Engineering New Zealand. Jason spent a decade as a rocket scientist at NASA before he and his family relocated to New Zealand in 2009. He soon became one of New Zealand's first certified passive house designers, and in 2016 travelled to Germany to further training and exams to become the country's first passive house certifier. Jason is an in-demand speaker at passive house conferences in Australasia and has taught courses for FINS, the Passive House Academy, and the NZ Green Building Council.
Awesome.
And AFA as well. So,
there we go.
Association.
The Australian version of FINS.
I have so many questions already, and I'm sure everyone here wants to just like pick your brain. So
cool. Well, I'll keep it short then, and we'll fly through it. And then we've got so if you really want to use what we're talking about today, there's an online video that kind of covers it in real detail. So what I'm here to talk about today is a tool we have available in Excel, which is called the Carbonator. So what it does is calculate the overall life cycle analysis carbon for building, both embodied and operational, using a couple other tools. So it's a smash up between an Excel sheet, an additional Excel sheet that does embodied and operational carbon, and passive house planning package, which is an energy modeling tool. So PHPP is an Excel sheet that does an energy model for building, kind of like NatHERS does in New Zealand. It does a simplified energy model, both for cooling and heating demand. And its secret sauce is that because it's been simplified enough that you can actually see what the hell is going on, it actually teaches you building physics as you use it. And so the part of the reason for this tool is to let my staff and me basically you can learn operational embodied carbon analysis as you use the tool, because you can see what the hell is going on. It's not just a point and click, one click LCA style tool. As was said, I run a small business called Sustainable Engineering. We do consulting primarily in New Zealand. We also do 4 or 5 projects a year in Australia, mainly either really big projects or special folks that know me personally, or maybe there's an over amount of demand in Australia. I think we've got probably 4 or 5 passive house certifications going on in Australia right now. So Carbonator. So what the Carbonator is it's an Excel sheet that you open up, or it's an Excel tool you open up next to the passive house planning package Excel tool, and it sucks over, and you type in the name of the Excel tool that has the energy balance in it, and it sucks over all the materials and areas from that energy model tool into another Excel sheet, which then calculates the carbon impact over the life cycle, right? And in New Zealand, because we've had a little bit of advancement in our tools, at least theoretically, we haven't actually put them in our building code yet. We've kind of laid out the map we're going to use in New Zealand for how we're going to regulate buildings' energy use and carbon emissions through construction and operation. And this is kind of the graph that we'll end up using in New Zealand with different cycles, which I'll go through in a sec. All right. So the first point I want to make is we've got 2 different grids we talk about. We'll talk about New Zealand a tiny bit, and then we'll mostly talk about Australia. So there ain't no such thing as a zero carbon grid. New Zealand's got huge renewable energy penetration in their market. Like our overall grid at times is 85, 90% renewable energy. In the wintertime, during our spikes, it's more like 50%. That's another story. But if you look over time, if we look at different plans for how we're going to decarbonize our grid, basically out here where the line gets flat, don't know if you can see my cursor in 2040 to 2050 range, we still have a reasonable amount of carbon being emitted by our grid. And that's because renewable energy has carbon emissions, both in transmission, maintenance, washing down solar panels. Geothermal energy has carbon emissions because you're emitting carbon that would stay in the earth through your emissions, all that stuff. So there ain't no such thing as a zero carbon grid in New Zealand. The thing to notice in this graph is it's 0.1. So 0.1 kilograms per kilowatt hour of electricity in New Zealand, between 0.1 and 0.2 pretty much all the time. In Australia, it's around 0.7, depending where you are exactly and all that jazz, right? And the reality is that this is recent numbers. They were just published in 2023 for Australia. This is the average for the whole country, which has been unfair in some regions that have more renewable power and such. The thing to notice is that in Australia, the transmission and distribution carbon emissions in Australia. So even if all the electricity is produced by panels, just moving it around the country, if you could magically move it around the country, the carbon emissions is still almost 0.1 kilograms of carbon per kilowatt hour of electricity. So you're never going to get to zero. So operational always matters. And basically in the future, when you have nearly fully renewable power in Australia, like you chuck all the coal burners off and you only spin up the gas in the winter when you really need it, when there's no sun, you're going to have a grid that's very similar like to New Zealand where it is now. So just realize that when we're talking about this stuff, there is no zero carbon grid. You can't just wait for everybody else to fix your shit. So we built this tool so we can include it in our initial design process when we design buildings. So we could basically, because nobody wants to pay for a carbon analysis of their building, so it had to be super quick, like a couple minutes, literally, or else we couldn't afford to do it for our clients because very, very few will pay for it. We want to be flexible enough that we can look at crazy stuff because we often get crazy clients that want to use things like aerogel or what if I use 5 panes of glass, that kind of stuff. And we wanted to be compliant with future legislation in New Zealand and make it in Excel so we can tell what the hell is going on, right? And make it compatible with past loss planning package. So that's what we built. So the tool basically has 2 pieces in it, embodied carbon. And since this is a sustainability network, I assume that most folks here are familiar with embodied carbon, but it's all the carbon associated with making materials from taking them out of the ground all the way through throwing them away. And ideally you calculate all the way through disposal. And you also take into account if you renew or reuse or either reuse material like aluminum where you just melt it back down again, or you reuse material like reuse timber, or you dispose of it by burning it at the end or throwing it in a landfill, right? So it counts all those bits of things, and those different things have phases from A is where you're basically getting the stuff through construction phase, cycle A. B is where the building's in use. C is when you're basically taking the building apart, and then D is where you get to recycle it or reuse it, right? And we talk about how that happens with embodied carbon. So that's kind of the material side, right? And embodied carbon is incredibly easy to calculate from one perspective, in that basically you just got to calculate how much you have of that stuff, how many square meters you have, or how much volume you have of that. And then you just basically multiply by a carbon intensity factor, right? And that carbon intensity factor we'll talk about in just a sec is from an environmental product declaration. I'm sure most folks are familiar with, we won't go into that too much, but basically it's a badness factor. You take how much crap you got in the building, multiply a badness factor, and you're done. You've got the embodied carbon, because all the complexity is hidden away in this PhD project inside the EPD, right? And the important thing is that the EPD talks about you use the right EPDs. So this is an example EPD from talking to folks in New Zealand, and there's a lot of EPDs already available for Australian products being manufactured in Australia, and those ones we would use. And basically talk about the same thing. They've got the carbon emissions in the different phases. So the A phases, when you're building the building, the C phases, which are when you dispose of the building, and the D are the stuff when you get to reuse it or recover it, right? And all the EPDs have a table like this where they talk about the global warming potential or the carbon emissions, and basically just have badness factors that account for how that material goes through. And the important thing is that you use an EPD that's applicable. This one is applicable for New Zealand manufacturer and European distribution and end of life, which is kind of freaky, right? It's because they want to export this. The reason they made this EPD is to sell a Bodo product in Europe, right? Because New Zealand loves to export timber to other countries because we're really good at growing trees. So the embodied carbon is relatively straightforward. All you're doing is using the tool that has the building geometry in it to do energy modeling, multiplying by a badness factor of that material to get the emissions in the different phases. So it's basically a giant sum if statement in Excel, right? It just takes a column of how much area you've got times how much stuff you got in each layer, times its badness factor to get the carbon, right? And it's broken down in these phases. So if you have maintenance requirements, it keeps track of those maintenance requirements in that Excel table. So it's just an accountant exercise. I mean, actually, in the future, the best people placed to do this sort of work is going to be quantity surveyors, not engineers, right? Because they deal with the quantity materials of buildings, and they deal with cost estimates, and they're going to be way better than engineers at this kind of work. So it's just kind of a temporary thing for us. And then operational carbon's a little bit more fun because you have to do an energy model. And you could use something like NatHERS. In this case, we're using the past files planning package. we put in, and the important thing is that the energy model, whatever it's designed to be, is predictive. So the reason that pass-fail planning package is real popular is because it is a tool that is intended to predict the energy use of the building, so it doesn't ignore the physics that matters. Things like NatHERS or other energy modeling tools can do as well as PHPP. There's nothing wrong with them. They're not bad. It's just the way we use them tends to ignore a lot of reality. But the bottom line is basically you calculate how much energy you need for heating, cooling, plug loads, water use. And water use, by the way, can be quite carbon intensive, both in New Zealand and even more so in Australia. And then you basically get a carbon flow for the building. You get embodied carbon at the front, operational carbon in green, and little blips as you do replacement cycles of materials in a building and the end of life. All right. If you want to see this demonstrated in detail, where we actually go through where you plug the numbers and stuff in, you can go to this page and you can download the tool. It's an Excel file, like I said, and you pull up a pass-fail planning package on your own that you have to have purchased and know how to use. And then you can link the two together and really quickly get a carbon output. In that tool, it has New Zealand grid factors, but it's literally one box that says 0.12 for the carbon factor. Just put 0.7 in or 0.65, whatever you think the Australian grid is, and you'll get numbers out that make sense. All right. And the goal is to have this, right? We've got 6 different buildings modeled in that package all at once. And you can then show the client, well, here's your bar graphs for your different buildings. And see, here's your existing building at 600 kilograms of carbon over its 50-year life cycle. Well, if we just fix the windows and ventilation in that building, because you're building a new building, this is actually for a renovation, by the way. Then you get down to 500. If you go ahead and also insulate the basement ceiling and the roof, you get down to 350. If you also fix all the walls and the entrance door and all the stuff before, you get down to, like, basically you can see as you add these colored bars here, which is the embodied carbon. It's like as you're adding additional, when you're fixing the windows and ventilation, you're adding additional carbon at each of these stages, but the operational carbon is producing so much over the next 50 years that it makes sense to do that all the way down to something like a pass-fail in this particular case, right? So I can show the client a graph like this for in this case, a deep energy retrofit, and see that, and give them assurance that they're not basically putting so much carbon into the windows and such that they're actually doing a bad thing, which, believe it or not, is a thing for a lot of our clients. And that's pretty much it. There's not a lot, because it's a free tool. We don't have much ability to provide support. If you find any bugs, let us know. Otherwise, the support you have is those videos that are online and you can download it. And it is really just a bunch of sum if statements. It's not magic or rocket science. Okay, with that, let's chat.
That's awesome, Jason.
So what I do have is I could share the website we can look at. I can jump to that real quick.
That'd be great. Thank you.
Let me share this screen. This is the website I was showing to you right here. So this is the page you'll see when you go there, and it's got a recording of an hour and 20-minute webinar, I think I did. So in that, I went through the tool and details. We can just jump to that. So this is a safe way to do an online webinar, right? Online review. So the tool itself, so this is a simple calculation. So basically you have the tool itself, and you can basically, you go into the tool and there's a read tool that basically walks you through the steps you go through. And there's 2 versions of the tool, or 2 ways to use the tool. The simplest version is like your normal pass-fail planning package tool, where it's for a single building. And that is like a 5-minute exercise. So basically you pull up that PHP file, you go to the README file and read that page, and then you look in your PHP to make sure it's working effectively, but you don't touch the PHP file itself to do a single building. You just leave it alone. And then you can go back to the tool and you put in here in the spreadsheet, so you just type in the name of the file and then set variance to no. And then you basically just go through and pick the constructions you have. All right. So in other words, tell it what the walls, roofs, and floors are, that they're actually walls, roofs, and floors. And then you go over to the next sheet, which has, you're not using the variance sheet, obviously, because you're just doing a single building. And then you go to the elements sheet. So that's setting walls, roofs, and floors. Then you get to this sheet here, right? So this is the element sheet. And on this sheet, you have layers. So for example, if you think about, let's just think of a wall assembly. If you think of a normal Australian wall assembly, you've got gypsum board on the inside. You've got a 90 mil stud wall with fiberglass insulation, a weather-resistant barrier. And then if it's a good building, it'll have a cavity and then cladding, but it may not have a cavity. Anyways, it's got cladding, right? And what you need to do is you need to put those layers in as materials. So we've already got materials that we use a lot in there, and they're reasonably good for Australia once you fix the grid factor, right? Which is just on the data sheet, by the way. It's this one that's called data right here. There's just a grid factor. It's a single number. You can just type 0.7 and then you're sweet. And those numbers are for New Zealand products being manufactured and used in New Zealand, but you can go ahead and put your own EPD data in. And basically you get the EPD sheet like I showed you a little while ago for a Bodo product. And you type in the 5 numbers for the different phases, right? And then the only other thing you have is you have a maintenance cycle. So then you have your layers, and that gives you your layers, and then you go across that same sheet. I think I talked about putting the EPD in, and you build an assembly over here, which basically you just call in the layers and see how much there is. So basically you put the layers in vertically in a set of tables, and then it puts them all the way across the top of the page. You just put how much you have in each layer in a square meter. So if you get a 10 mil gypsum board, you put in 0.01, right? Because it's 10 mil, so 0.01 times 1 square meter gives the quantity of gypsum board, and just go across. And that's it pretty much. And then it just takes the quantity times that amount you put in the column and adds it up, right? And then displays it. So it's really quite straightforward. And that's all the fancy tools do as well. It does do a little bit more than that. You put maintenance cycles in, and if you're using paint, for example, every 7 years it has repainting happens. So every 7 years you have a blip of embodied carbon with painting and such. But there's no need to make it more complicated than that, because you get results out that make sense, right? And because you're only doing it yourself, you'll often realize that, for example, weather resistant barriers go in. We use, Tyvek, or if using Proclima wrap or something, right? The embodied carbon materials are so small, it's much less than 1%. So we'll often not put them in our models because we know the result won't change because of them. So that's the thing that you get out of using a tool like this, where you can see what the hell is going on, rather than like something like one-click LCA, where you're putting in every little product, even stuff that doesn't have an impact, because you really don't know what's going on and what has a bigger impact or smaller impact, because you just don't see that stuff. And it also means, so you don't learn what goes on. You just kind of get a final result that, it is likely to be more accurate than this tool would be, but it doesn't teach you what the hell's going on. So this tool's really only suitable for folks that like using PHPP, Pascal's Plain Package, and like hacking around in Excel. If you're not one of those people that likes those two things, don't touch it. Use one-click LCA. Actually, is a new software coming out that we've been involved with that does energy modeling and embodied carbon in one tool. Lots of other tools use those.
Thank you for this diving through the spreadsheet. I guess I loved what you said about the quantity surveyors probably being the most appropriate person in the workflow to do this kind of work. And I've had sort of similar conversations with other sort of assessors and people in the space, and typically they're the ones that have all the data around that kind of stuff. They already have all the numbers. When it comes to a concrete slab, you've got the footing thicknesses and all of the beams and everything like that. And it becomes quite hard to just be like, okay, this is an appropriate calculation. At least with a quantity surveyor, they just have the numbers available. So that was awesome. Yeah, great insight. I think that's probably where we move.
I have one question, Jason. When it comes to the Excel sheet you've shown, what if we have multiple floors or multiple units within the building? Will it still be applicable? Can we still punch in the data and get the results out of it?
You mean when there's multiple units in a building, like multifamily? Yeah, so that works. There's all kinds of value judgments hidden in our language. I'm sure you know that. And coming from the States, I can see it a bit easier in New Zealand because I didn't grow up here. But we talk about things like kilograms of carbon per square meter of building, right? It means basically that we value floor space, right? Not people, right? But it's really difficult to do kilograms of carbon per occupant, but that might actually be a much fairer metric, because what this means is if you build a really big house with a huge amount of interior volume and really high ceilings, which has less surface area per square meter of floor area, it's inherently going to have a better carbon efficiency. And that's true for energy as well. So just realize that these tools and the way we talk about them is inherently got a huge amount of value judgment hidden away. And the engineers just pretend to ignore it because we just like numbers, right? Like me, I just love numbers, right? So I just don't want to think about it. It's just too hard. But just realize that. But yes, it's very applicable for multifamily because you use square meters of floor area. So the difference you'll have is that you'll have walls and floors that are not external walls and floors. So in this tool, there's an area we can basically just put additional, you can put like a garage that's outside the envelope. So you just need to make sure your mid-floors, and there's a line for mid-floors and intertenancy walls are in there.
Right. Okay.
Yeah, but it already has an internal wall thing. Basically, you put in construction in for an internal wall, which in New Zealand's 2 layers of jib and a bit of studs, right? You just put the linear meter of how much linear meter of internal wall you have, and it's the same thing. Right?
I'm just trying to understand. Sorry, another follow-up question there, Jason. Now, when we are entering all these details, it's human tendency, we make mistakes. Are there any integration tools as such, where we can connect and fetch this information and get the results through Excel?
So in New Zealand, it's easy to use the high performance construction details book we put together, which has all the A phase embodied carbon done by a professional quantity surveyor and us, and then checked by brands, our Building Research Association New Zealand, professionals. And they went through that. And at some point I pissed off a lot of them. So they were really trying to find mistakes. So it's very, very well checked. And they also helped me out too. Wrong. But anyways, so they check those numbers. So in New Zealand, it's pretty easy to compare your wall construction, your emissions up to construction against that book to make sure you've kind of in the right ballpark. But I don't know of a catalog resource like that in Australia. So unfortunately, it'd be easy to build one, and it might be a fun crowdsourced project to do something like that. We pick your standard constructions and develop a standard wall element. What you'll often find is that because timber tends to be negative carbon, it stores carbon over the life cycle of the building. It's obviously released at the end. Most of the carbon is emitted with the claddings and the paints. So the wall itself is actually pretty good because gypsum is relatively low carbon because we import gypsum from Australia to New Zealand and we make it into gypsum board, right? It's a relatively low energy process. And even the shipping, the gypsum is relatively low energy. Thank you. So the wall, most of the badness factor in the wall is the cladding. So once you have a standard wall element built up, you can just swap out the cladding or the paint as you do it. When you do these life cycle analysis of buildings, you'll often find, especially for multifamily, that the largest carbon emissions are going to be the concrete and steel in the foundations typically, and the carpet. The carpet is what kills it. So don't put carpet in. And it's not that carpet itself is real high carbon. It's just to replace it every 5 years or 7 years. And multifamily might replace it every 4 years with tenancy turnovers, right? So replacing that carbon, it's a lot of material. So whether it's wool or, we're always trying to sell wool, whether it's wool carpet from New Zealand or, synthetic carpet from anywhere else, it's just a lot of energy being used, right?
Well, thank you, Jason.
Go on, Zeemon.
All right.
Yeah, let it go, man.
Yeah. All right. So it looks like the Carbonator tool is best suited for, when you're running variants in PHPP, you got a few different designs, and then you're obviously looking at the energy model with a client on each of those designs, and then you can look at the embodied, and the operational carbon. So when you're running, because you touched on it a little bit with that retrofit example, when you're running variants in PHPP, how easily does the Carbonator tool just grab every variant, or are you running the Carbonator tool individually on every variant, or it just plugs into the whole model?
The first time you use it, you run it individually for each variant, right? Because then you don't have to touch the PHP. The PHP is still virgin. We haven't corrupted the PHP file. Like you just use it. You just type the name in, right? And for a single building, you can do that at once, right? If you can use the variants file and you want all 6 variants to be linked and update, then you have to go into the PHP file, unlock the sheets, and put some equations in. Basically, because the variants, when PASFILE's planning package calculates variants, it does a bunch of buildings at once, any number effectively, but usually we use 6. So the file set up to only do 6. So you do 1 or 6, by the way, is the first trick. You can change it, of course, to use any number you want, but then all the graphs, you'll have to change every graph, right? And what PHP does is it uses a feature in Excel that lets it calculate more than one building at a time by using data tables. And the stuff we need out of those data tables isn't all in the variance file already. So we have to add some rows in the results file in the data tables to store those values for each of the 6 variants so we can grab them out, right? So that's why we had to break the Excel file, or we had to alter it. It doesn't break it, but it just adds additional things. It's relatively straightforward. It's cut and paste. Those directions are in the tool to do that, and it's in the video as well. So it shouldn't be too hard, but it is much more high level than just just using it. So the first time you use it, don't use a variance, just use a single PHP file and just use it. But then once that's done, it's completely live, right? So if you change the installation in the variance file, then the operational carbon will immediately change in the tool. However, if you change the area of wall, it would immediately change. But if you change the insulation value in the variance file, like the thickness of the R value of the insulation, it won't know. So you'll be able to see that in the tool pretty easily, but just it's not everything's, anyways. So the areas are dynamically linked, but the materials and the layers are in the tool itself. So those need to be changed if you change things.
Cool. So when, say I'm a passive house designer and I want to add this to my services, how much additional time, once you get fluent with the tool, do I allow? Because you said it's very time cost effective because you're offering it almost for free to clients. How much time?
It is free. We don't charge anything extra. So.
Yeah. How much time should I, as the designer, be allowing per run of the Carbonator tool on every variant sort of thing?
So if you have a standard process where you have 6 variants,
yep,
and you're putting them into the tool where you've modified it so it has the database in there, then bringing up and you're using the same constructions that you always use, then it doesn't take any time. It's maybe 5 minutes, right?
Yep.
If you're going to modify, if you're going to do 6 different claddings, then you've got to get 6 different EPDs, put the numbers in the tool, and then run it again, right? For those, because you can have different claddings in there. And that'll take however long it takes. I have no idea how long that'll take you, but I would think a couple hours would be reasonable.
Yep.
So it's a couple hours, which is a big chunk of money. A couple hours is a lot of money.
Yep.
So yeah, it's really good because most designers, ourselves included, the majority of our projects, we use the same constructions. And we do sometimes have clients that are really not interested in the carbon tool, and they come to us with crazy tilt slab stuff with aerogel or whatever, and they don't really want to know what the carbon is. And in our contract, we'll just be like, we won't do carbon in this project. We try not to do that because we really like to try to do it in every project. But if we've, rather than building in assemblies and putting that time in, we just tell them we won't do that part of the project. But we generally try to do it for every project.
So like setting up your common assemblies in your PHPP as your template file, you set up your Carbonator tool with common assemblies, and once that's done, you've done a little bit of homework for yourself and invested in your company, but once that's done, you plug it in and you run it, and it literally takes you 2 minutes, basically.
Yeah, I mean, it takes more time to screen grab the graph and make sure that everything's been updated than it does to run the tool, because you just have to name it, right? So, and that's like, PHRibbon is way better, by the way. So I didn't mention that tool. PHRibbon is another Excel plugin tool you can get from the UK, and it does operational carbon and embodied carbon as well. And that tool is way better than this one, right? So if you're the kind of person who's gonna, serious, laugh at me, Ken, it's okay. It's a way better tool. I've used it myself. The problem is that it's not archived with the project, so you have to have a license. If your license expires, you no longer have access to the tool. If you got 6 staff, you need 6 licenses. That's another problem. And it takes a half an hour for every project to an hour every project, every variant. So if you got 6 variants and you actually want to do the carbon for all 6 variants, it's like 5 hours, right? Which, if your client's work, it really wants to know about carbon stuff, it's a better tool. It's got a lot of stuff built in. It's got a large database of embodied carbon stuff built in already. It's all UK stuff pretty much, but it's easy to put in the Australian grid factors and use Australian EPDs as well. It's a professional tool, like it's got support and all that stuff. So it's a really good tool, but it is really good in detailed design. And that's where I would use that tool. And that's where we do use the tool. We've got one license and we have one person who uses it during detailed design if we need to. In New Zealand, we use another tool called LCA Quick, which is, again, it's another Excel tool that does not only, I should tell you the truth. Life cycle analysis is for all kinds of things. It's not just for carbon. It's also for things like waterway eutrophication, resource depletion. You can do anything, right? You can do anything you can assign a badness factor to. So you could do like, I don't know, you can even do like a community health score, right? If you could figure out how it's impacted by different materials, then you could have a score on materials on how it impacts community health or something, right? So, so the LCA-R tool just looks at carbon, obviously, because that's all you're putting in. In theory, I guess you could put any set of numbers and use it for anything, but it's used for carbon. LCA Quick is a tool that's funded by our Building Research Association here in New Zealand. And again, it's a New Zealand focused tool, and it's not unlocked, so you can't change things, unfortunately. But it again, in some ways, it's better than this tool. Unfortunately, that tool, a typical building, is like a day of work. It's like 8 hours, right? So there's no way you can afford to do that for a resi project. unless the client's really interested in it and wants to spend money. So we've used LCA Quick in several residential projects and use this tool at the same time. We use this for initial design. We use LCA Quick for detail design. And we charged like, I don't know, 15 grand for consulting using LCA Quick on that project because that's what it took, right? We didn't, that was discounted. Like it was a developer who was really had money to invest in a research project, right?
Can you tell us a little bit? You said that you're working across here in Australia as well. You've got a few projects going on. Tell us about sort of, working in New Zealand and also working in Australia. Tell us a little bit about your experience between the two systems. I'd love to hear a bit.
Yeah. So I pretty much have mostly worked with people that know me. So as a pass-fail certifier, it's pretty much all I've done. So is there anything else? Oh, and a few foundation systems and some moisture problem modeling, that kind of stuff. Some CLT failures, some other failure investigations, and a few legal cases, but not very much really. So the big difference I see in the construction industry in Australia and New Zealand is that if you look at a residential project for a pass house project, it's got a really detailed drawing set. It's like it'll have sections through the door sill to the garage, telling you how the thermal break below the door sill connects to the insulation below the slab or the insulation in the suspended floor, right? It's got, so like you actually can build a building from the drawing set if you're just an engineer and like a real builder. Like you could actually just kind of follow the directions, right? So Australian drawing sets are not to that level of detail. New Zealand regular construction projects are almost at that pass-house level. So they won't have a section through the door sill to the garage, but they will have all the window head jamb sill kind of details. So it's so the big difference I've noticed in Australian and New Zealand projects isn't materials or anything like that. It's just the level of detail you go to and through in construction is very different. And that's because we had such a big fiasco of leaky buildings and our councils are just require that level of detail in the drawing sets. Otherwise, I mean, the buildings I tend to work on tend to be really high performance. So otherwise they're pretty similar.
I've got a question. I've got a question for you, Jason. So all of us, I guess, being involved in some capacity and being LCA practitioners, looking at embodied carbon and trying to drive change. Do you see the Carbonator being an applicable tool for early use in optioneering phases when you're talking about, hey, we're going to go option A versus option B? And if so, how do you recommend plugging some of those gaps when, say, you don't have a preferred product or you don't have sort of a, you're in the phase where you're sort of ideating with the client. You're looking at saying, okay, we want to drive down embodied carbon. We don't have all of the points yet. Do you have any preferred ways of plugging those assumptions?
Yes. Don't put zeros in is my recommendation, right? So that's what happens, right? People put in zeros. So it's like, oh, we don't have a number for that. We'll just assume it's, and inherently they don't put it in. So therefore it's assumed as zero, right? So my recommendation is if you don't have a cladding material because the client has no idea what they're going to use, then hopefully you've done more than one project. But if it's your first project, find a cladding that you might use and use that. Don't use zero, right? And pick a reasonable one. Like don't pick the best one in the freaking market, but pick a reasonable one so that when they come in with their cladding, you're comparing it against that, right? So one of the big sins, or I guess carbon impacts that people don't realize, they'll build a certified pass house trying to get operational carbon down, and then they'll save money by putting metal cladding on the whole thing, right? Which is much higher carbon impact, even where we use iron sands and we're going to recycle the steel at the end of its life cycle than any sort of timber cladding, right? So we pretty much the best cladding we use, in other words, cheapest to put on the building that has really good sustainability criteria is WeatherTech from Australia. So don't need to pitch Australian products to Australian people, but it's all right. So WeatherTech, that's what we used on the Loco house in Auckland, which is a developer built research project, and it doesn't have such low carbon because of its timber content or because low shipping carbon, although those are both true, but because it doesn't require coating. So basically most of the building is not going to get painted and is never going to get painted. And that's a humongous carbon impact, right? So the only parts of the building that are painted are in the porch, in the back of the porch, where they won't need coating very often. And you don't need a scaffold or anything to get to. So it's there's a large carbon impact on maintenance cycles and such. So that's why I say don't put in zero. If you pick a cladding, pick a coating, put the numbers in. And then the nice thing is you have that one done. And when you do optioneering, just always use that. it becomes a WSP cladding system we use, right? Fit out in paint, and then you do that. So if you look at the high performance construction details book, which has only A phase carbon, embodied carbon in those numbers, so it doesn't have use or disposal or maintenance cycles in it, that has inherently assumes timber weatherboards with paint, but again, only for initial construction up to turnkey carbon in it, right? And those are only good for only resi stuff, right?
Yeah. I mean, my problem is I work in defense, and so we're busy building metal.
Yeah, but there's a lot of really good stuff out of Canada, right?
Totally.
And I would use, RDH has got heaps and heaps of stuff out of Canada, so you've got a much better database than the poor resi guys.
No, I completely agree. A follow-up question on the database from NZ. You say A phase. Are you talking A1 to A3 product phase, or does it have some assumptions as well for transport and for construction?
A1 to A4 is what I meant. So we do typically, so it depends on where you get your numbers from, right? So there's an A4 column in the tool. So the transport, and actually I think A4 also includes wastage on site.
Transport, and then one A4 is transport, I think, and A5
A5 wastage.
A5 construction.
Yeah. Thank you. But yeah, so A4 and A5 are transport and wastage, right? So the numbers that come out of LCA Quick, which is where we often steal our numbers from, include an assumption for A4 and A5. So the numbers in the high performance construction details book do include A4. They assume the project's in Auckland, not in central Auckland, but like kind of the 20 kilometers outside the center. And then it assumes that there's normal site wastage from a very good QS in the South Island here in New Zealand. So you're right. When you're computing you have a badness factor, and often the EPDs will exclude wastage on site. So you need to adjust your quantities by your wastage factor. Obviously, if you're building multifamily or you're building in a factory, you have very low wastage because you're designing that out to make profit. But a lot of resi builders, because labor costs are so high, wastage is not considered, just practicality of running a real business, right? And so wastage it impacts the usage you have at the front, right? And usually any decent QS will have typical wastage, because when they're figuring out how much the building's going to cost, they're kind of calculating that in at the beginning. But transport in New Zealand's relatively efficient. Just mileage from Auckland that kills you, right? It's but Aussie, I guess it could be quite different because you guys are so big.
Yeah, definitely big fluctuations. Thank you very much for that. And I guess as a follow-on, and I guess as maybe a slight asterisk warning piece for anyone who is offering it to clients, I would absolutely recommend that you explicitly state your assumptions as well, because obviously if we're saying, hey, it's this number, it's always going to be subject to's, right? When doing those rapid things, there's always like, how long's a piece of string? But it's really cool to see the tool, and thanks for that.
Yeah, it's when you're comparing different configurations, relative differences can be really impactful. So you've got a past house planning package model of the building for energy consumption, which is pretty good. And we're considering all the energy, not just heating and cooling loads, right? Water is a big bit. So for this tool, we've just pulled the water numbers out of LCA Quick, because those numbers have quite a bit of research behind them. But in Australia, the numbers could be very different for water. In New Zealand, on average, it's like 1/3, 2/3. 1/3 of the carbon for water is in supply, 2/3 in disposal. I don't know what the hell it's like in Australia. I'm sorry. I don't even have a clue. But it can be quite large impact over the lifespan of the building. It might be 10% of the operational carbon of the building is water, right? Obviously, if you've got a really high energy use building, then it would be less. But for an efficient building, it could be 10%, which is not insignificant. But one thing that's good is relative comparisons. So if you think about if you're comparing two wall assemblies and you think there's going to be the cladding that's driving it, then if you know the rough scale of magnitude of how big the carbon impact of the wall is, then it doesn't matter if you've ignored fasteners or like steel staples or whatever, right? We've done studies to look at how much metal there is in a typical wall, timber stud wall, and it actually is quite small impact, like it's less than 1%. So don't let the details kill you. It's okay to just get 2 EPDs for cladding and say, well, this cladding is this many kilograms of carbon extra per square meter. And the total numbers, total number for the cladding is 15 and this one's 25. Like that's, and the wall is typically something like 100. You can look at the HPCD, see what it is. So therefore, it's 10 over 100. It's 10% more for this. The whole wall assembly's got 10% more carbon than this one, right? For this cladding. And that often is enough to understand what the hell you need to do to make a decision and move on with your life.
Are you sure you want to tell people that are working with PHPP not to think about stress the details? Are you sure you want to do that, Jason?
Yeah. Yes, I do, but
I
don't.
thought
Yeah,
I
you
thought
can
that,
quote me on that.
that
Yeah, you're right. There is a certain psyche that happens there.
I was about
But
to say, it's like, if you're
yeah,
doing
yeah.
this with
Well,
me, you do
PHP
it
is
with me.
all actually, to tell you the truth, PHP is all about that, right? So
Yeah, that's
PHP
what I'm
doesn't
saying.
look at the solar game on the floor, right? Whereas Energy Plus does, right? If you use Energy Plus for dynamic energy modeling, like you can actually see what the impact of the color of the floor has on the model. Bugger all is the answer, by the way, but it can have a small impact if you get a dark colored concrete slab versus a white concrete slab in a passive solar style house, right? And you can't look at that in PHP because the physics for most buildings is bullshit. Don't look at it, right? So PHP's got the simplified physics in it, so you can understand what the hell's going on. So that's what I'm saying, is that it doesn't make sense to try to get so much in the details that you get spun around the axle and don't get to make forward progress. But you're right, there always is a catch with that. But I don't think I'll get hung out and tarred and feathered by the folks at PHI just yet.
So Jason, you were saying about the water. If say you're building an off-grid building, I know like water storage and things like that, and energy storage. I know the PER sheet in PHPP doesn't factor in batteries, and I don't think water storage is factored in at all for
Nope.
the passive house planning package. But in the Carbonator tool, are those sort of storage systems factored in a bit for the operational carbon? Because
No.
still not.
No, they'd be included. So the batteries would be included in the embodied carbon, right? So if you're doing an off-grid building, you need to put the PV panels and the storage and probably the racking system at the very least to kind of get a ballpark number, ignoring all those details, for the additional embodied carbon you've got in there. And then the operational carbon then becomes very low because you just have the maintenance of the PV system, because all the electricity comes out of the PV panels is been paid for by that humongous embodied carbon of those panels. And it's only the last generation of panels, like the last 10 years, 15 years, where the panels are producing enough electricity and the panel production process is low enough carbon that they actually make out in carbon over the life cycle. So if you use the latest numbers, and assuming somebody's not screwing with the data too badly overseas, which is a possibility, but a lot of the research actually comes out of Australia, then it seems like basically you get a 2-to-1 ratio. So if you put in panels, you get basically, and you put in 100,000 kilograms of panels in a big central system, you're basically saving, in the New Zealand grid context, in Australia it'd be much better. You're saving 200,000, right? So you get 100,000 net. So you get about half, right, over the 25 or 30-year life cycle of panels. In Australia, because your grid's so dirty still, the panels will be much better, much sooner, right? So they would give you a bigger total building life cycle operational embodied carbon payoff.
Tasmania excluded, right?
Yeah, that's true. Yeah, Tassie excluded.
So
So it's interesting.
Switch off the grid factor completely, or is there an off-grid mode in your Carbonator tool, or you just turn down the grid factor to say it's, because I'm producing clean energy off my own roof and storing it overnight, I can bring that grid factor down? Is that an assumption that you then make there?
So if you're fully off grid, then you're not using any grid power. The grid factor is 0.
Okay.
You need to track your energy internally on your site because you don't have a grid factor.
Yeah.
You're not using anything in the grid. It also means that you can't offset it, right? So if you're putting a bunch of PV panels in your building and you've got a battery storage and you're going to put enough panels so you have enough power in the winter when the sun's low, then and you might have higher demand because you're at altitude in Adelaide, so you actually have a heating dominated building, then you'll find that you're throwing away a heap of power, right? So you're getting nowhere near the whole panel production annually into a useful thing, right? So it gets interesting. In reality, your whole building turns into embodied carbon, and there's no operational carbon except for maintenance cycles when you're bringing in stuff or you're washing panels off. So it completely changes the picture. So the way you do that isn't by adjusting grid factor, it's by considering everything is embodied, because that's what you're doing, right?
And then
you're basically prepaying for your electricity with carbon. And
then you do the same for the wastewater and your fresh water to the house. Does that have a grid factor in the?
It does if you're on a grid system, which means you're connected to mains. But if you're isolated and you're using, let's say, rainwater, you're using a pump to pressurize it, and the pump's also off grid, then everything's embodied. You're not on a grid.
Yeah.
There is no grid to count. So the way to think about it is if you just like you're in design PH and you got a 3D model of your building and your site maybe, and you got like just draw a big square yellow box around the whole thing. Anything that crosses that yellow box in or out, you need to account for. You can ignore the sunlight, let the rain in and out, that's all free. But anytime you drive on the site with materials or you drive off site with materials or you bring energy in and out, that's when you count it, right? That's your control volume. So because in your case, you're bringing a bunch of panels in, well, rain won't count the rain. So you get a bunch of panels inside, and then you're going to stay inside that box, your panels and batteries for the life cycle of the building, or every 20 years you need to replace the batteries. So you drive a new set of batteries in and you drive the old set out. So that's the way to conceptualize it. And it becomes a research project because it's pretty much all embodied carbon at that point. So.
Cool. And last question from me. Does it plug into EasyPH or is that still separate?
Yeah, no, EasyPH isn't easy, first of all. EasyPH is harder to use than regular PHP. It's easier to show a new passive house designer that they just have to fill this one sheet from top down, but it is very different design process. And in my opinion, you still need to use design PH anyways, because the shading in classic PHP is not sufficient for overheating protection. So you're screwing your clients if you try to use classic shading methods. We still need to use design PH to generate a 3D model, which we can import it to EasyPH easily. That works. But then you've got this one sheet you've got to fill out. And the reality is, if you want to do anything that's not super German standard, like you would do in Darmstadt, Germany, like which you will not do in Adelaide, you're going to have to customize stuff, which means you're going to want to go back to a regular PHP file. So we've got one client in Aussie who's using EasyPH, and if I had known they was going to use EasyPH for the project, I probably wouldn't have accepted the contract because we've spent an additional 40 hours in that project over a normal project because it's EasyPH, because we've had to ask so many questions of Germany and work through a lot of stuff. So no, it doesn't work with EasyPH.
Fantastic. Well, we might wrap up there, Jason. Thank you so much for your time. That was fantastic.
Yeah, great.
All right. Well, I had fun. Enjoy it.
And for anyone else who's out there, Jason runs great courses. I've attended a few of them with Finn's, in collaboration with Finn's, and just by himself, part of Sustainable Engineering. So check out his courses when they show up. Follow him on LinkedIn. He's always posting about some great new course, which are
awesome.
really helpful because they go above and beyond what you learn normally as part of like your certified passive house designer. It's actually more going into the practical application and all of that. So, and he's a wealth of knowledge. So yeah, check out the courses he runs because the time difference isn't actually that much. It's quite easy to attend from here in Australia as well.
Yeah, awesome. Thanks so much, Simon, for sharing that. Yeah.
No, all good.
No
Thank
worries.
you for the shout out.
Yeah.
Y'all enjoy and
appreciate
happy
it.
Christmas.
Merry Christmas.